All right, this video will review the topics that will be on the quiz on Thursday. We have gone over how to work with exponents and also how to multiply polynomials like the FOIL method. We also talked about all the financial math, and I will go through an example of using each of those formulas. Again, you will be given a formula sheet, so you do not need to memorize the formulas. You just need to know how to set them up and use them appropriately. You also need to have a calculator that can do exponents. Any scientific or better is fine. And if that's going to be an issue to obtain one, please reach out to me and we will make that work. Okay, these are the properties that you are responsible for knowing. When you multiply, divide, or raise another power to another power. Okay, multiplication, if I had like x to the 6th times x squared, that would be x to the 8th, right? We would add the exponents. If I did x to the 6th divided by x squared, that would be x to the 4th. And if I raise a power to another power, then I multiply. Okay, x to the 6th to the 2nd would be x to the 12th. Anything to the first power is just itself, and often we'll go the other way, so we'll have an expression like this, and you'll need to remember that there's really that hidden 1 that we just don't write. Anything to the 0 power is just 1, and finally, if you have a negative exponent, you can instead write that as division. So for instance, if I had like 5x to the negative 6, I could instead write that as 5 over x to the 6. I will go through a few examples of using these properties, and of course there was practice on Blackboard from a few classes back that you could go do. Okay, on the quiz I would ask you to do something like this. Okay, simplifying, and whenever we simplify we're always using order of operations. Okay, so we start with exponents. Okay, in this case this 2, which will only distribute to the exponents in the right set of parentheses, and don't forget there's really a 1 on the 5 that also needs to be distributed to. Okay, but it doesn't go to this parentheses, only the 1 on the right. So I'm going to keep this the same. 3a, b to the negative 3, c to the 8. Okay, keep that the same. This will become 5 squared, a to the 8th, b to the 8th, c to the negative 14. Okay, just multiplying each of the exponents. And then, of course, 5 squared, I can turn that into 25. 5 times 5. Okay, now we multiply. Okay, when we do this, it's sort of like combining like terms. We multiply the numbers. 3 times 5, or 25, is 75. And then I multiply each of the variables together. So a and a to the 8th. Okay, remembering that there's really a 1. And again, when we multiply, we add exponents. Okay, so this will be a to the 9th. And then doing the b's, negative 3 and 8 gives me 5. And then 8 and negative 14 gives me negative 6. Okay, the final thing I would ask, and on the quiz it would say, only leave positive exponents. So we're just going to bring this to the bottom. And that is our final answer. Okay, another example with dividing. Okay, here we just want to reduce as much as we can. With the number, we talked about you just want to treat that like it were a normal fraction. So just if you saw 20 over 25 and I asked you to reduce that, you would pull a 5 out of each, right? 5 out of 20 and 5 out of 25. Okay, and so that's what we'll do. So that just becomes 4/5. And then we subtract, right? So 5 minus 2 is 3, and 8 minus 12, right, is negative 4. Okay, so always do the top minus the bottom. Even if you get a negative, that's okay, because then if we get a negative, we're just going to bring that to the bottom. And that's our answer. If you left it like this, I would take a point off, but it's correct, but just it's not how most professors are going to want you to do it. So All right, the other thing I would ask you to do with exponents are some basic polynomial operations. So distributing, for instance. Okay, if I had something like this, we're going to do the distributive property. And again, we multiply the numbers. So 5 times 6 is 30, and we add exponents. 3 plus 2 is 5. Okay, and then we just go down the line and continue to do that. So again, this is really a 1. 5 times 2 is 10. 3 plus 1 is 4. And then for the last one, there's no x's here, so we're just going to multiply the numbers and keep the 3 x's. And that's your answer. You can't combine these any further because those terms don't have the same exponent. And the last thing I would ask you to do is good old FOIL. If you learned that first, outer, inner, last, you can also just think of it as doing the distributive property twice. Okay, so I'll start by distributing the 2x. 2x times 3x, and then it would be 2x times negative 4, right? And then we distribute the 7. Okay, so it's 7 times 3x, and then 7 times negative 4. You don't have to write it out like this. Some students find that helpful. You could just distribute without writing it that way. Just it helps you see like 2x times 3x. Oh yeah, that's going to be 6x squared, right? Because I have 2 x's, right? An x to the 1 and x to the 1. This will be negative 8x. This will be positive 21x, and this will be negative 28. And then we would simplify here. We can combine like terms, and so that would be 13. And that's my final answer. Okay, that doesn't go any further. All right, that is all the algebra that will be on the quiz. The other part of the quiz will be all the financial math. Okay, so I'll just go in order that I taught them. So the first one we did was simple interest. Simple interest is where you earn the same amount, right? You start with some starting amount and it grows at a linear rate. So it's a steady climb. You always get the same amount of interest every single year. Okay, this is the formula. On the formula sheet, it's going to have all this stuff because that's what they're going to give you on the final exam, but we're really just going to use this part right here. All right, again, A stands for the final amount. P stands for the principal, which is the starting amount of money. R stands for the rate, but we have to put it in as a decimal. So again, you think of like 3, right? You move the decimal 2 spots to the left, right, to turn it into a decimal. And then T is the number of years. Okay, so setting that up, final amount is going to equal the principal times 1 plus the rate times the number of years. And of course you would want a calculator to do this, so just give me one moment to find that answer. And I get $6,500. And that's it. That's all you have to do. Just set it up and get a final answer. You would get 1 point for the setup and 1 point for the answer. So please do show that. Please don't do the work all on the calculator without writing it down. Okay, compound interest. A little more complicated to compute, but again, you're given the formula. You just need to know how to use it. The letters all stand for the same thing. The only new letter is this M, and that is the number of compounds in a single year. Okay, so like if you read this problem, in this case they use monthly, so that would mean 12, but if they said daily, that would be 365, right? If they said every quarter, that'd be 4, or quarterly, I guess, that'd be 4, and so on and so forth. The only time you would not use this formula is if it said compounding continuously, and we will do an example of that in a moment. Okay, so setting this up, the final amount Okay, we invested, just like last time, $5,000 into an account earning 3.5% interest, so that would be 0.035 divided by 12, right, because we're doing monthly compounds. All of that raised to the 12 times t, which is 20 years. Okay, if you were computing this, you could do it all in one go if you're setting it up with parentheses, but probably easier just to break it down into steps. First thing I would do is clean up the exponent. All right, 12 times 20 is 240. Then I would compute this part. So do this on your calculator. Do 0.035 divided by 12. Just gonna do that. I get 0.0029, and then I'm just going to immediately add 1 to that. And so I'll write that down. It's 00. So just go to it'd be nice if you could go to 3 significant figures, right? Things that are not 0. And then you just want to type that in. So do this number raised to that power, and then multiply it by 5,000. And so again, just give me one moment to compute. And multiply it by 5,000. And I end up with about $10,066.54. Round to the nearest cent. And I'm not going to be so picky. If you're off by a few cents or even a few dollars, you're going to get it right, because it just depends on how we round. As long as you show me the setup. As long as I can see that, as long as it was set up correctly, if you are off by a few dollars, I'm going to assume it's just a rounding thing and give you full credit. Okay, so show me as much as you can. All right, compounding continuously. This is a different formula. Okay, so anytime they use that word, this is the formula you're going to use. And setting it up, everything is the same in terms of what the letters stand for. The only thing is this E business, which, on most calculators, there's an E button or an E to the X button. And E is this constant. It's about 2.1-ish. That's good enough for me if you know that, or 2.7 rather. But most calculators have that built in. Okay, so we'll write E to the 0.035 times 20. Okay, again, R is the rate and T is the years. And on most calculators, you can type that just like this, which is what I'm going to do. Just give me a sec. And again, if you can't find your e to the x on your calculator, please just ask me and I will be glad to locate it. Any scientific calculator or better has it. Okay, this is the number I get. Again, you may get a slightly different number if you round. Okay, notice it's only a little bit higher than the last example. Okay, that happens, right? If you do the same amount of money with the same interest rate for the same amount of time, what you will find is that continuous interest earns a little bit more than compounding monthly or daily or anything like that. Okay, we talked about how it's the limit to compounding. And again, compound interest grows, instead of linearly, it grows like exponentially, right? So it grows faster and faster over time. All right, those are the easier formulas to use. Then, of course, there are the 3 slightly more difficult formulas, which are the savings formula, the payment formula, and the amortization payment formula. And I will go through an example of each of those. Again, there's also practice on Blackboard, and I will post a review sheet as well if you want to try these. Okay, so the savings formula is used when you make repeated deposits over time. Okay, usually like a retirement account would be a classic example, or just you are putting away money toward something that you're trying to save up for, and you are making a regular monthly deposit of the same amount. Okay, so here's an example. You are making a monthly deposit of $400. That is what D stands for in this formula. Again, all the other letters stand for the same thing as before. 15 years at an interest rate of 3%. Okay, so setting this up, Now this is a little more to calculate. Okay, so 1 plus the interest rate this time we'll just go back to 3%. M, again, is the number of compounds or payments per year, and they are telling us it's monthly, so it's going to be 12. Almost always when you use these formulas, we're just going to use 12. Okay, T is the number of years, and then 0.03 divided by 12. Okay, so setting that up again is worth a point. Then we talked about in class how it's easier to kind of break this down into pieces. So what I'm going to do first is calculate this, which works out to a nice number, I believe. Yeah, it's 0.0025, so just write down the whole thing. Otherwise, again, just round to 3 significant figures if you could. Okay, don't lose the 400 in front. And then notice that this is the same fraction, so we're just going to add 1 to it. And then clean up the exponents. So 12 times 15 is 180 minus 1. Okay, so then now take your calculator, right? Do this calculation. So do the exponent first and then subtract 1. And I'll tell you what you get. So you get 1.56 and then subtract 1, so you get 0.567 if we round off. Now divide, right, the top number by the bottom number, hit enter or equals, and then multiply that by the 400. And so I'll do that. And multiply by 400, and I get about $90,000. 90,720. And no sense, just because we rounded. Depending on how you round, you might be off by several $100s, and that's okay, as long as you show me that setup. And it makes sense. We should get a big number. We were putting away a lot of money for a long period of time, so we should end up with a large number as our answer. Okay, the opposite question would be the payment formula. This is where you are saving, but rather than asking like how much money am I going to have if I put away this every month, you're asking the opposite question. If I want to have this much, how much do I need to save? Okay, you are solving for this monthly deposit. Last time we knew it was 400. Now we're asking what would it have to be? Okay, so we'll set it up. A is the final amount, which we know, right? We want to have $50,000, and we'd like to have that in 10 years. 2% interest, so 0.02. Again, we are making monthly deposits, so 12. And if you look at this formula, you will notice it is the same formula as last time, just literally flipped over. Okay, so like if you flip that, it's just the same thing. So calculating this is no more difficult. Right, it's just going to be in the opposite order. Okay, so I'll go ahead and calculate this. You might want to just pause the video and try it yourself. Just give me a minute to do that. So I get 0.00, so it's 16666. So just again, like if you could just round off to 3 significant figures beyond the zeros, that'd be great. And then again, just add 1 to that, right? It's going to be the same exact decimal, just with a 1. The exponent is 120. All right, then I'm going to go ahead and calculate the bottom. And I get 0.222 if I round off. And then again, do top divided by bottom. And multiply it by 50,000. And I get a final answer of about $376.13. Okay, so again, that is the monthly deposit I would need to make in order to end up with $50,000 at the end. So this time the answer should be small, right? It should be something in the hundreds because that's our monthly deposit. All right, final example, and this one will be a little more involved, is the amortization payment. This is where you are paying back a loan of some kind. A mortgage is just a type of loan for houses, but this could be like a car loan or a student loan or any situation where you are borrowing money and paying it back. Okay, you are not saving your money, you are paying it to somebody else. Okay, the formula is just a little more complicated because there's like a negative sign in the exponent, and we have to be careful about the subtraction here, but otherwise everything is set up the same. Okay, so D stands for the monthly payment, P is the principal, so the amount of money that we borrowed, and then it is, let's see, 0.035, 3.5%, 12 months because we were doing monthly payments. And then just again, be careful of this negative sign here, raised to the negative 12 times 30. Okay, which I'm just going to immediately turn that into negative 360. All right, again, I will calculate the top, and you may want to pause and try this yourself at this point. Okay, so 0.035 divided by 12, I get 0.00292. And so it's going to be 1 minus 1.00292 to the negative 360. Okay, with the bottom now, you just got to be careful. Okay, do this. And then write that decimal down. So let me write that 1.00292 to the negative 360. Write that decimal down. So 0.35 if we round off. Okay, then do 1 minus that number. Okay, so you get 0.65. So all of that just calculates down to this. Okay, then do the top divided by the bottom and multiply by the 220,000. And we should get something reasonably small. Okay, $988.31. Okay, again, your answer may be a little bit different depending on how you rounded, but it should be close to that number. It should be something in the 900s, maybe the low 1000s. And it makes sense that it is a smaller number because it is a monthly payment. If you got an answer in the billions or the millions, nobody could ever afford a house. It wouldn't make any sense. The last thing I would ask you to do, right, you found the monthly payment. Okay, on the quiz, I would also just ask you to tell me what is the total amount that you pay. Well, this is the monthly payment, right? This is what you pay per month. And so the question is just how many months are you going to be paying back? Well, you are doing 30 years. 30 years is 360 months, right? If you multiply by 12. It's always just, this number is always just going to be the same as this exponent here, obviously without the negative. And so we're just going to multiply the monthly payment by the number of months. Okay, so let me do that. And we get about $355,791.60. Okay, so the unfortunate reality of loans is you borrow $220,000, but you pay back a significantly larger amount of money than that, right? And that's the effective interest. So the total amount should always be bigger than the amount you borrowed. And if it's not, right, you did something wrong. All right, that is everything on the quiz. There is a review sheet on Blackboard that has an answer key so you can check that you're doing it right. I would recommend you at least look at it and pick out the problems that you don't know how to do and try those. If you have any concerns, any questions, send me an email. The quiz will be on Thursday. And again, please bring a calculator. I will provide the formula sheets. All right, hope this helped. Let me know if you have any questions. Have a great day.